You just learned the steps for determining molecular formula. You may notice that the first 4 steps are the same steps as determining the empirical formula, because the first step in determining the molecular formula is to first find the empirical formula. So you should recognize these first 4 steps. Once you have determined the empirical formula, to determine the molecular formula, you need the whole number factor that is multiplied by the empirical formula to give your molecular formula. In order to find this, you will need the molar mass of your empirical formula, and then divide the true molar mass, which will be given in the problem, by the molar mass of the empirical formula, and round that number to the nearest whole number. And then that will be the factor that you will multiply to give you your molecular formula. So of course, these steps will always make more sense as we do an example. So let's take a look at the problem here. It says the insecticide Lindane has a percent composition of 24.78% carbon, 2.08% hydrogen, and 73.14% chlorine. You are given that the molar mass of the compound is 291 grams per mole. Determine the molecular formula. So this molar mass is considered the true molar mass of the compound that you are looking to determine. So you are given the mass percent of each element within the compound. Those mass percents are used to find empirical formula. Then the true molar mass will be used to determine the final molecular formula, as was just discussed. So following our steps, we begin with recognizing that we are starting with percentages. So if we're starting with percentages, we must check to be sure that those percentages add up to 100%. So if you add together 24.78, 2.08, and 73.14, you will notice that they total to 100%. Therefore, we can assume 100 grams of the compound and convert each of the percentages into grams. Now we're going to transfer over to the board here and we'll go through the remaining steps. So I already have our information on the board. So you always want to start with, organizing the given information from the problem. So we were given the percentages of each element that we can assume as being the grams per 100 grams of the total compound. Okay, so that's what we're starting with. And once we have the grams, we convert each of the grams into moles because we want to figure out the whole number mole ratio between the elements to determine the empirical formula first. Okay. So the same steps of empirical formula, that's what we're doing first. So we're going to convert the grams of carbon into moles of carbon using the molar mass. There is 12.01 grams of carbon per 1 mole of carbon. And when you do the math here, what you would get is 2.063 moles of carbon. You will notice that I rounded to 4 significant figures because we started with 4 significant figures. Next, we have 2.08 grams of hydrogen. To convert to moles, 1.01 grams of hydrogen is in 1 mole of hydrogen. Therefore, when we divide, we will also get 2.06 moles of hydrogen. Remember to have your calculator with you so you can be doing these calculations along with me. Okay, so 2.08 divided by 1.01 gave us 2.06 moles of hydrogen. And I rounded this to 3 significant figures since we started with 3 significant figures here. And that's the least number. Then for the 73.14 grams, we're going to convert that to moles using the molar mass of chlorine. 35.45 grams of chlorine per 1 mole of chlorine. When we do this math, we get 2.063 moles of chlorine. Okay, so what we see is that these are all in the same ratio with each other. This would be like saying 1 to 1 to 1. If we divide by the smallest, which is basically the same for all of them. So just to go through the process, I'm going to divide each one by 2.06. And what you get is 1 mole of carbon to 1 mole of hydrogen to 1 mole of chlorine. Therefore, the empirical formula, okay, so we got the empirical formula now. The empirical formula is going to be equal to CHCl. Okay, so remember, this is the molecular formula has been reduced to the least whole number ratio. Okay, so that's what the empirical formula is. Now, to determine the molecular formula, we need to figure out what that whole number factor is that will be multiplied in order to give us the molecular formula. To determine that whole number factor, we need the molar mass of the empirical formula and the true molar mass that is given. Okay, so let's take a look here. If we would add together 1 carbon, 1 hydrogen, and 1 chlorine, the masses 12.01, 1.01, and 35.45, each from the periodic table for carbon, hydrogen, and chlorine. We add those together to give us the molar mass of the empirical formula to be 48.47 grams per mole. Okay, so this is the molar mass of your empirical formula. So right now we're taking the true molar mass, 291, dividing it by the molar mass of the empirical formula to determine the whole number factor. So we're going to do the division here, and when you divide, you're going to see that it can round to the whole number 6. Okay, so that's your whole number factor that you will multiply by the subscripts of the empirical formula. So now your molecular formula will be equal to C6H6Cl6. Okay, so in this case, it turned out that since everything was 1 to 1, then everything here has a subscript of 6. Okay, but you just multiply the factor by whatever the subscripts are within the empirical formula. Okay, it won't always all be 1 to 1 to 1 in this, like in this case. Okay, so whatever the subscripts are, you multiply the subscript by the whole number factor that is determined by dividing the true molar mass of the compound by the molar mass of the empirical formula. And then you find, we found that the molecular formula is C6H6Cl6 for this compound. It's the insecticide lindane.